Okay, so let's use the last example to put it all together. Here we go. I have a hypothesis test greater than or equal to, so this is going to be a one-tail test. Okay. Sample of 50, so my n is greater than 30, so I have a normal distribution, x bar equals 19.4. That is what I observe. I know the population standard deviation. Good. So I know that I'll be using a z distribution, a z critical value. Let's calculate this test statistic first. Standard error, I'm going to go ahead and just do the calculation within here. Okay. Put it all in the calculator. This is what you should get. All right. Next, using alpha of 0.05. Okay. So go ahead and sketch out your critical region. It's going to be a left tail test. So my critical value, it's going to be over here. If you look that up, you're going to get a negative 1.645. Okay, so where's my test statistic? So if I looked at this, my test statistic, if this is negative 1.645, my test statistic is over here. Right? It falls to the left of that, so it is in rejection region. So we will reject a null. So we can say we have enough evidence to conclude that mu is, so there's enough evidence to suggest that mu is indeed less than 20. Okay, all right. Let's go ahead and give the next one a try. Okay, set a random sample size 6, so n equals 6. Oh, so that's not big enough. So we might not have normality, but wait, we are getting this from a normal population. So okay, we're making that assumption here. Sample mean 11.17, sample standard deviation equals 2.14. Okay, so it does not say here we don't know this. Oh, sorry, it doesn't say here we know the sigma, so we must use the t critical value. All right, let's perform a hypothesis test to test the claim that the mean is equal to 10. All right, so our hypothesis, let's go ahead and write it down here, is that the mu equals 10. Then naturally our alternative hypothesis would be that the fact that mu doesn't equal 10. So this is going to be a two-tail test. All right, so let's go ahead and calculate our standard error this time on the side. Okay, it's going to be the standard deviation divided by the square root of the sample size. So that will equal, try that in the calculator. Okay, and let's go ahead and calculate our test statistic. Okay, put that in the calculator. Here's what you should get. Okay, now let's look up our critical value and determine our rejection region. This is a two-tail test, so I'm going to split my alpha into both tails. So each tail is going to get 0.05. Again, alpha here, 0.05. So that's going to be my critical value. Now, I need my degree of freedom when I look up, because I'm using a t distribution. So my degree of freedom, 6 minus 1, is going to be 5. So go ahead and use the app, look up the critical value, and what you should get is 2.57. Negative 2.57. All right. Now, my test statistic, 1.339. Where does that fall? That falls to the left. Right? So remember, after we convert everything to test statistic, 0 is going to be in the middle. So 1.339, that's going to be here. Right? That's where my test statistic falls, is in the acceptance region. Whoops. Acceptance region. Therefore, we can, a couple statements we can make whenever we fail to reject. We can say we fail to reject. Whoops. Can't spell anymore. The null hypothesis. Or we can say we accept the null hypothesis, right? Or you can say there's not enough evidence to reject the null hypothesis, right? Or there's not enough evidence to suggest that the mu is not equal to 10. There are literally hundreds of ways you can state this. However, right, here's one way you cannot say. We cannot ever say we just because we fail to reject null, we cannot say we support the null hypothesis. We never say this, right? We can't say we support the null hypothesis. We can't say we support that mu equals 10, right? Simply because that's not how hypothesis test works, right? Hypothesis test, we can only support something, right, by rejecting. We can only support something in the alternative, right? So when we test a hypothesis, we're not here to support it. We're here to see if we're able to reject it, and that is it. All right, so that's it for 9.1.